छोटा hello, we will start it at start the class at 4:40 because 4:40 is the scheduled time of starting. Yeah. Okay. Yeah. So it is good to ask questions about assignments, but it is not a very good idea to discuss the solution of the assignment. I thought it was understood from your assignment. Okay. So an assignment doesn't mean that you have any clarifications on some problem. You can ask me. But if it is if you have a solution, you want to explain the solution to me right now, that's not a very good idea. Okay. Because the assignments are graded and it is important that everybody tries to solve it by themselves. Yeah. Okay. Any other questions about the assignment?
No, sir.
Yeah. Any doubts or something? Yeah. So
yes, sir.
So there's a very important point. Yeah. Go ahead.
For number 4, it is said that if the input format is not correct, then it can output error wrong format of input. So I mean, for binary search, the array should be in sorted manner.
Exactly. It has to be
that, that is the if the user doesn't if the input in a sorted manner, so that is the wrong format of input, right?
Yes.
This
Yes.
case.
Yes. Yeah. If the input is not in the sorted manner, or if the things are not integer, or if the input is not in that form, right? It is not a third bracket with this kind of particular format. You can say it is wrong input. Okay. Yeah. Any other questions?
Sir,
yeah.
In question number 1b part, so it is written, prove that 3 measurements are not enough if n is 13. So, sir, my means I can solve it in 3 steps. So, should I proceed like that?
If you can solve it in 3 steps, go for it.
Okay.
Give me a solution that how you can solve it in 3 steps.
Yes, sir.
So in that case, you will prove my problem wrong, which is perfectly fine if you can prove my problem wrong. So you are saying that I have written that the question is that prove that 3 measurements are not enough, and you are saying that no, actually 3 measurements are enough, and you are giving me a proof. Yeah, I mean, it is very much possible that I make mistakes in various places, and you can give me you can prove me wrong by giving that thing. I don't think I'm wrong here. So I can just give you a hint that you are not. I mean, if you have come up with a 3-step algorithm, or algorithm with 3 measurements, then possibly it is not right.
Okay, sir, I'll recheck my calculations once.
Sir, in question number 4, it's not written anywhere that input has to be in sorted order. So, because
okay, so in that case, it has to be there.
But the binary search needs
because of binary search, then we are assuming.
yeah, so you has it, sorry, if it, yeah, it has to be in sorted order. Yeah, good point. So I will possibly take, I mean, I will update you guys, or for everybody. Yeah, the fourth problem, the input, the list has to be in sorted order to make it valid. So the valid input is a sorted list of is a sorted list of integers. Okay.
Okay.
And
And
it
in
should be
number
given
two,
in third bracket, right?
and it has to be in the third bracket and separated by commas.
Okay.
Okay. And the second one is you are only allowed to do multiplication and addition. In the
And
second problem,
for question number 2 and 3, you need to give proof of correctness.
you have to give proof of correctness. Yeah. Yeah, you have to give proof of correctness. Okay. So any other question? Any other question on the, I mean, on the video, not necessarily on the assignment? I mean, Uddalok asked me to explain, I mean, give one explain of the proof of correctness of some sorting algorithm that I am anyway going to do. But other than that, okay, no questions whatsoever. So I can ask you guys questions about various things.
Sir, hello.
Yeah.
What is the average time? How do we find the average time for selection?
How do I put the average time for selection sort?
Huh.
Okay. I mean, did you try it out? Do you know? I mean, did you understand what an average time is?
Yeah.
You understood that?
Yes.
Okay. Did you try to solve it? Find it?
Sir, I tried, but I cannot do.
Okay. Okay. So I will get to go over it. Okay. Any other? One second. I need to do some stuffs. Because I think without that I am unable to do it. Just one second. Okay. So let me, you can ask a poll. Please tell me which of these videos actually have you gone over? There are 4 videos. Okay, I mean, I don't know how to tell you guys. You guys are all adult students. So if you guys don't cooperate, then nothing much I can do about it. Okay. But as far as I understand, that's a look at that in the sorting videos out of, I mean, only 7 of you have gone over it fully, and only 15 of you have gone over it partially, which means that around, even among the set of people who are there in the class, 10 of you have not even looked at that video. And it is up to you, it's your life. And I can say that if you struggle in your course, then that is not my problem. If you don't put in the effort, then I am sorry, I cannot help you out in any way. This is something, I mean, really unfortunate. And I will, what I will do is that I will take a quiz sometimes very soon. And in that quiz, if you guys, I mean, whoever is not doing well or something like that, I'm going to report to the dean's office saying that, okay, these are the people who are like not doing well, and you guys decide what to do with them. I mean, if you don't put up, you don't even read them, then nothing much I can do about it. I don't understand why am I taking classes otherwise. So, by the way, I can also tell you one simple thing. I am giving you guys the option. If anybody, if you have not seen the videos, okay, I am now going into sorting algorithm. I'm not going to talk about sorting algorithm. If whoever has not seen the sorting algorithm videos, and if it is that you don't know sorting algorithm beforehand, you might leave this meeting. It will be completely useless for you guys. I mean, it will be just a wastage of your time. Okay. So let's look at this merge sort. Okay. So what is the merge sort that we do? So in the merge sort, what is it? So what is the input? So let me quickly go over this merge sort algorithm. The input is basically an array of n elements, right? A1 to an, and you want to output the sorted list. And the algorithm, basically what it does. So basically what it is that if I give you a merge sort, right? So merge sort of a array A of 1 to n. So this is the array. So what does it do? It first of all partitions this array into two parts. It first of all divides it into, say, in the middle. What it does is that it says that, okay, here is the part 1, here is the part 2, and says that, okay, go and merge those two, go and sort them individually. It is something like, say, if I have a deck of cards and I have to sort them, and I have two assistants, what will I do? I will just say that, okay, take the first half of the deck of cards and I give it to first assistant and say, okay, you go and merge it. And sorry, not merge it, sort it. So first of all is that, so let's say this one, say B of A1 to AN over 2, let this be the what I get when I sort them. Sort what? The first n over 2 elements. So B is a sorted list. And similarly, say Bn over 2 plus 1 to Bn is what? This is a merge sort of A of n over 2 plus 1 to n. So what basically what am I doing? First of all, I'm saying is that okay, here is the first half, A1 to AN over 2. You go and sort it. And once you sort it, I have this object. This sorted list is my merge. Is my sorted list. This B1 to Bn over 2. And similarly, I have this second half, and I sort them. Okay. Now I'm writing it like this, but I don't need to write it technically like this. I could have written it as A1 to AN over 2 also. So this is called something called in place sorting. What? So I am saying that, okay, go and sort this one, and whatever the sorted array is, you can put it here in the original place. Okay. Now at this point, what do I have? At this point, I have this array B you can think of, which is basically the old array A only. In the middle, this first one, so this is sorted and this is sorted. But these two are together not sorted. So I might have something like 1, 2, 5, 9, 3, 5, 9. Yeah, that is 5, 9, 9, say. And I can have something like here 2, 3, 4, 5, 6, 7, 8. Now individually they are sorted, right? So this part is sorted and this part is sorted, but together it is not sorted. So the next thing that I do is what is called a merge operation. So merge of this, both of these things, these two. So merge B of 1 to N over 2 and B of N over 2 plus 1 to N. Now what is this merge thing doing? So now see here, I have defined this merge sort using two operations. One is I have defined it using merge sort itself on a smaller set. It's a recursive call. And also I have defined another one, which is the simple merge operation. Now, basic idea is that what does the merge operation do? So merge operation will take two sorted lists and merge them. Okay. Now how do you do that? Okay, we have to write it carefully. Okay. So maybe I can write this definition like this: merge of C comma D. There's two different. Maybe I will just, for the sake of it, I will just write it C of 1 to N and D of 1 to N, 1 to K. Okay, two operations. And this assumption is that both of these inputs are sorted. And I want to write down how to do it. So what do we do? The idea is that I will, in this kind of place, I will maintain two pointers, I and J. And I will keep on merging them and filling them at a place which is a different sorted list, say S. Okay, so I will start with I equals to J equals to, so this is initialize, sorry. This is initialize I equals to J equals to K equals to 1. Okay, my job is that I will take this sorted things and I will finally write it up in a new array, which is, say, in what we can call it as, say, C. Okay, a C. No, C. Sorted, I don't want to have it C here. Say S. So you can think of that. Maybe I should forget this one. So this is a C, this is D, and I want to merge them, and I write the whole thing, this merge stuff in S. And I have these three pointers. I have I, J, and K. Initially, everything is set to 1. Now, what is it that we do? First of all, I have to find out what to put here. The first one. Which one should I put? Which one should I put? So one thing is that I will at any point of time be at this place, right? I look at this two, the minimum one will go here, right? So basically, I guess I can write something like this, that what do I? Sk equals to minimum of Ci, minimum of what? Ci and Dj. Okay, so I have whichever is minimum. So here either this point or this point, whichever is minimum, I will write it here. Okay, and then I will go and write something over, and then I will kind of move on. So the idea is that once I have written it here, I should move this k, right? I should, of course, sorry. Yeah, so basically I should kind of move this k to the next step. So how do I do that? Say I have this one, I will move it to the next step, right? So in other words, I would say that, okay, I have done with this right now k, I will move to the next one. So that means I should update k equals to k plus 1. And which one should I update here? What I should update here is, I should update, so if I have written Ci over in Sk, then I should update Ci. I should push Ci, and else I should push Cj. So if Ci is less than Dj, then I equals to I plus 1, else J, else is what? Which is else? So else basically means that Di or Dj is less than Ci, which means that I have written Dj. So then J equals to J plus 1. And this is what basically the algorithm is, right? So in other words, if say I have written Ci over there, in this case Ci, then I will update this one. And this is how I will continue. Okay, so this will, maybe I should write it here. Yeah, so this will help me to merge two things. Give me any two sorted list, I should be able to do it.
So when will it complete?
Sorry?
That when will the program terminate?
When will the program terminate? So tell me, when will the program terminate?
If I keeps increasing,
Yeah.
For example,
Yeah.
In this case,
Yeah.
I will increase for first case, I will be increased. Second case also I will be increased.
Right.
In the next hop, J will be increased.
Right.
In the next hop, again I will increase.
Right.
And then J will keep increasing.
Right.
And then I will keep increasing.
I mean, are you giving an example for this particular example?
Yes, yes, yes.
Yeah,
for this, for
in
this.
general, but in general, can you tell me when will it?
But I didn't understand that when will it terminate? For example, that J will be, if J is pointing at 8.
Yes.
And I is pointing at 9.
Yes.
At that point of time,
yes,
I will again increase to 9.
Yes.
Next element, and then again 9. So at the last point, again it will check, right? So I will keep increasing. There is no termination.
So
right?
there is no termination. So how
I
do
mean, this will terminate. I mean, each one of the arrays smaller than 10, right?
Right. So one thing that I have not told you, and which is a very good point, is that I have not told you termination point. So this whole thing will be while Ji is less than the size of n, I is less than n and j is less than k. You do this whole thing. Of course, see, if when in the last thing that comes out here, I say is that is I has like moved to here, okay, and j has moved to say here. At this time, I should terminate, right? At this time, there's nothing to go. So that means I has to be, the I is this one, right? What is I? I is from 1 to n and j is from 1 to k. So at this point, I should stop. I've seen all of it, right? Now there are some catches again that are there, that what happens, I mean, you go over it and all, but the main idea is that after this point, so at some point of time, as you pointed out, let's say j is here and I is, say, in this case over here. The j is here, right? At this time, I mean, I should, I mean, yeah, so let me not go into this thing. Let me leave you guys to think about it, how to do it. What is happening?
আমি ক্লাসে আছি পরে আসছি।
I cannot even do control my pen. Whatever. Yeah. So when I'm here at the end, at that time it should kind of stop, right? And this is exactly what you should be doing. So you should continue till I comes to the end, j comes to the end, and that's it. So any questions about this
So this is not in place sort, right? In place short algorithm.
Yeah, this is not in place sort, because although till now, when this merge sort and all those things I told you was in place and all those things, but here when I'm doing the merging, right, I am creating a new set S and then doing it, right? Now you can do it in place also by a little bit of trick. So what is in place? So here I am creating a new set, a new list S, which is different from the space taken by C and D, right? But is it possible that I don't reuse new things? I don't use new area, a new space and do it. So I don't know. I will let you guys think about it. How can you convert this one to a in place sorting?
So we can swap it.
If we use linked list,
If you use what?
Like the same method, if we can just without putting the element.
Yeah, you can do something of the sorting thing. Yeah, you think about it.
if we use linked list, then it will be this sort of.
If you use linked list, do you think it will be easier if you link list?
But easier, I don't know whether it will be easier, but in this sorting will be, I mean, we don't need to make extra space for.
Sorry?
We won't need extra space.
We will not use extra space, but in linked list we will be okay. Good. So maybe, yeah. So let's try to first of all understand why we are doing merge sort. Okay, maybe that will help us to understanding it. So why are we doing merge sort? The reason we are doing merge sort is an efficient algorithm. What is an efficient algorithm? First of all, I have not proved the correctness of the algorithm. That is what I am wanting to start. Maybe I should start with that. Why do you think that merge sort is correct? Okay, so there are three parts to the merge sort main thing. It has just sort the first half, sort the second half, and merge. Now it is clear that if all the three parts are done correctly, then I should be done with merge sort, right? I should have a proper sorting algorithm for the whole of A1 of the whole given list A. Okay, if you can sort the first half, sort the second half, and then merge these two halves, two sorted list in a nice merged way, in a nice sorted list, then we are done. So there, I think it is nothing to prove there. Okay, this place there is nothing much to prove. That if these three things are correct, then you will get a sorting algorithm, a proper sorting thing. Okay, now we can think that merge sort is correct. Let's try to prove it by induction. We can say that, okay, if we assume that merge sort is a correct algorithm for small enough numbers, for smaller size list, in that case I can say that, okay, then merge sort, the first array, the first command where I'm using merge sort to sort the first half, that also is correct. So this is the inductive proof. So by induction, I can assume that after this round, after this command, b of 1 to n over 2 actually gives you the correct sorted list of A1 to n over 2. Similarly here, then by induction, I know that after this command, this will contain the sorted list of an over 2 by 1 to an. Now that here it is, I have to use induction because this has a recursive call. Okay, now that is fine. This is inductive stuff. But what happens here? How can we prove that merge algorithm is going to give us a correct algorithm, the correct thing? So merge of two sorted lists will actually give us the sorted list. So the correctness of this algorithm actually is based on the correctness of the merge algorithm. Why is the merge algorithm correct? If we can prove that the merge algorithm is correct, then by induction, this merge sort is correct. Is this clear?
Yes, sir.
Okay. So now we have to therefore prove that the merge algorithm is correct. Okay. Now merge algorithm, of course, has a loop in it, a while loop in it. Okay. Fine. Now, can you tell me some property of this while loop?
Repeat the question.
Can you say, I kind of talked about the loop invariant and all those things. Can you have a loop invariance of this? What is the loop invariant property of this? How do you prove that the merge algorithm is correct?
Sorted array, like is the arrays must be sorted. Is that the loop invariant?
Which array is sorted? The C and D is given to be sorted. Yeah.
Yes.
S is sorted. It is, you're right. So the loop invariant is that S is sorted. So loop invariant, so there can be many loop invariants, but one loop invariant you can think of is that S1 to K is sorted. The sorted list. Okay. Now that every time K increases, so if I can prove that S1 to K is always sorted, is something that is satisfied by the loop, then at the end of the day, I would have got a complete you have got a complete sorted list, right? Now, how do you prove that loop invariant is loop invariant? So say in a particular state, okay, in a particular round, we start with S1 to Sk is sorted. Okay, so I can think of it this way, that at this point there is the S, okay, up to here I have filled out, and this is a sorted list. Okay. Now, what is the next one? How do I prove that this is a sorted list, sorted thing? How do we prove it? That the next one that I put in, okay, the next one that I put in must also be sorted. Okay, so at this point, so say at this point, let's say I am looking at the ith bit of C. So I mean, say at this point, where am I? Let me see. Write it down. Say this is C. Okay, in the C. So say my K is over here. This is my K, or K plus 1 rather. In my C, I am pointing at this point I, and in this D, I am pointing at point J. Okay, at this time, so this is the start of the loop. Okay, this is at this point, you can think of this is at this point in a particular loop. Okay, now what do? I will take the minimum of this and this and putting it here, right? Right. So I have to take the minimum of this and this and put it here, say. Okay. So without loss of generality, let's say that this is I put so say without loss of generality, let us assume that C of I is less than D of J. So in that case, I will put the C of I over here, right? So that means S of K plus 1 is equal to C of I. Okay, good. Okay. Now what? How do I? Yeah, go ahead.
Now pointer at C will increase by I plus 1 and compare with.
Exactly. I will increase the I to I plus 1, right? But see, all of those things will not change S. Okay, I will next change this one. But I have to convince myself that why is the loop invariant satisfied now. So I know that up to this point it is sorted. I have put here C of I. Okay, C of I goes here. How do I prove that the new thing, this whole thing gets sorted? So,
if not,
yeah,
at earlier steps, we would have gone wrong, right?
Exactly. If not, say, I mean, I have started
Hello?
with the assumption that this part is sorted, right? I started with the assumption that this part is sorted. That's a loop invariant. Loop invariant means you start with something and you come out with same thing, same property.
I mean, suppose that S of K plus 1 that we have chosen, Ci, is less than, we would have to show that it is at least greater than or equal to Sk, right?
Yes. So we want to show that S of 1 to K plus 1 is sorted, right?
Yes.
And we know that, and what do we know? We know that S of 1 to K is sorted.
Yes.
So say let us assume not. Let us assume that S of 1 to K plus 1 is not sorted. What does it mean?
then at least S of k is
S of k plus 1 is less
less
than
than S of k. Yeah.
Okay, good.
Then our earlier choice, like S of k comes from either C I minus 1, I mean C1 up to I minus 1. It is Ci minus 1 or Dj minus 1, right?
Exactly. Very good. So now consider what is S of k. What is S of k? So S of k is either Ci plus I minus 1, right? Or C or
D of
Dj
J
minus 1. I don't know. So that is exactly what we are doing, right? That's how we are moved to the next one. Okay.
And C and D are sorted, so it has to be.
Yeah. So now there are two cases. Case 1. If Sk is actually equals to C I minus 1. Now I have assumed that Sk plus 1 is actually equal to Ci, right? So I know the Ce is sorted, so this is less than or equal to Ci, which is equals to Sk plus 1. And hence, in this case, I know that it is getting sorted. So there is a, so it cannot be, right? So it must be that S is sorted.
Yes, sir.
And case 2 is say that Sk is actually D of J minus 1. But what does it mean? D of J
D
minus
of
1? When are you going to put Sk equals to D of J minus 1?
When C of I minus 1 is greater than
right. So
D of
that
J
means
minus
at that point, I must have been using this one. So at that time, I must have been looking at Ci, right? So this must be less than Ci,
Yes, sir.
right? Which is equals to Sk plus 1. And in this case also, this I can
Okay.
prove that S remains sorted. Yeah. Hello. Hello, Nirupam, I cannot hear you. Yeah. Nirupam, if you have any question, you can maybe send a chat or something. There was a lot of noise at your end. Okay. Any other questions? Anything? Is it clear that's what happened? So in this merge sort, not in the merge sort, in the merge routine, we proved that if you take this loop invariant, then using this loop invariant, I can see that this merge algorithm at the end will output an S which is sorted. Okay. And so the merge algorithm, when it stops, and it will stop at a finite time. Why? Because every time either I increases or J increases, and I and J are both bounded, right? So they has to stop at some point in time. And when they stop, what we get is the sorted list of these merged element of C and T. So this is the kind of the argument of correctness of the merge sort. Uddalok, is it fine? You had asked this question. Hello. Yeah, he's missing. Okay, good. So yeah, so when you have to prove something in class or in exam or something, you might not have to write so much. Just something like pointing out that there is this loop invariant is satisfied and the rest of the argument is kind of obvious is good enough for me. Once you can identify a proper loop invariant, that okay, see, merge is correct because in this loop invariant is satisfied, and I'll be, I mean, that would prove to you that prove to me at least that you understand the whole thing. Okay, and that will be kind of, the rest of it is kind of I mean, if you want to even give a proof, else it can also skip it also. Like this is kind of obvious to see that this loop invariant is satisfied. Okay. Now I must say that, okay, so with this, let me also talk about the time complexity of this merge sort. So let T n be the time taken or number
One
of,
question.
yeah,
Sir,
tell
is
me.
like if we are proving a sort algorithm, then loop invariant has to be something related to sort only, right? Or
No,
can we make it like
no, not necessarily. There was other way that I was thinking of it. Yeah, that makes sense actually. That at the end it will be sorted. Yeah, yeah. The
this,
loop will be.
if we say loop and invariant is that k is equal to I plus j or I plus j smaller
No, no,
than equal to n plus k, that don't make any sense.
that will not. That will be a loop invariant. That will not prove you the fact that at the end we will get a sorted array.
Yes.
Yeah, you have to come up with a loop invariant that which will end up proving that it is a sorted array.
Yes. Yes, sir.
Yeah. So let's say Tn is the number of steps for sorting n length array or list or array. Okay. So I mean, so array by merge sort. Okay. So this is Tn is the whole thing. Now let's see what did we do here in the merge algorithm, the merge sort algorithm. We first took a n length string, we split up into two parts, n by 2 and n by 2, right? And then we told that, okay, let's split it up, and now I can merge it over here. Okay, so that means if I can use a different color, maybe, no, maybe this is not good. Yeah, blue. So if t of n is the time taken by this merge sort, okay, then this one will take t of n by 2. Okay, and this one will also take tfn by 2 because they are all recursive. They will be taking it because they are of size n by 2. And now I have the merge algorithm. It takes some amount of time. How much amount of time does merge take?
Maximum of the size
n
of
plus
the
n.
It will be n plus n or n plus k. Why? Because every time I'm increasing either I or j, right?
the
And
maximum of the size of so that is
sorry,
maximum of maximum size of the I mean if
maximum number of rounds in the for while loop.
uh,
Yes, how many loops will be there?
So maximum of m and n.
It is not maximum of n and n. It can be m plus n. Because every time I'm not increasing both I and I or j. Every time I'm increasing at least one of I and j. Right? So you can think of this way that I plus j, this number starts from 2, slowly can go up every time. And at the end, it is at most, it must be less than n plus k, right? So n I plus, so the total number of loops will be actually n plus k, or sum of these two lists. Is it fine? Of course, there is some constant number of steps over here. So the total number of loops is n plus k. So the total merge sorts running time is actually some order of n plus k, where n and k are the two list. Right? Here both of them have the same size n. So this is something like of order n. Right? So what do I have? T of n is equals to 2 times T n over 2 plus order n. So this is the runtime of the merge sort algorithm. Okay. Now, this is the runtime in the worst case. Now, what does that mean actually? So that means after this many steps, the algorithm will certainly stop. Okay, and if you can solve this one, very good. If you cannot solve this one, I mean, I'm hoping that my MTech CS students know how to solve this one. MTech CRS students, if you have not seen this particular thing before, please try to go over the this stuff about the induction and the recurrences and so on, and how do you solve this particular recurrence relation. If you have trouble understanding it, let us know, but I will not spend any extra classes for explaining this one, because this is something that I have done in the discrete math course already. And you should be getting, now MTech CS students, can you please tell me what this value is?
N log n.
This will be order n log n. Okay. So this means that after n log n steps, this merge sort algorithm should certainly stop. Okay. Now, what is the, okay, this is the, say, this is the worst case. Can you tell me what is the best case?
N log n. N log n.
Why is the n log n best case? Why is the best case n log n? Huh? Sorry? Can you say it clearly? I cannot hear you.
Maybe giving already sorted array will be the best case, right?
Yeah, if you give a sorted array, what will happen? How
So
much time will it take?
after like how much time it will take? So just n comparisons with the first element of first jth position, right?
What? First jth position in comparison.
I mean, there is the subarray C and D were there, right?
Yeah.
And jth point will be at the first array only, and we'll compare every element from 1 up to n with the jth pointer, first position.
Yeah.
So that will be just n comparisons, and
Yes, this will be n. I agree.
yeah.
Merge sort will be n. That is there here also.
Then merging algorithm will be n, and what else is there?
Yeah, so actually you will
Improvement,
kind of,
there's no much improvement.
yeah, convince
Again,
yourself that the best case, okay, will also be this.
Unlog only. Okay.
I mean, somebody pointed out it should be theta. It has to be theta. That is not what I meant. Okay, this is theta. But even if you give a merge sort, a completely sorted list, then also it is n log n. This algorithm will do a lot of stupid checks and all.
So what about, like, I have a question about expected time complexity of this one. Like,
What is expected time complexity means?
like for every case we'll assign some probability, right?
I mean, have you looked at
Or
this
the
video,
average.
or are you telling it from yourself?
No, you said something about average time complexity, right?
Right. So what is the average time complexity? So the average
So
time
taking all the possible cases, right? Like given a sequence of length n,
the average time complexity is that you take all the possible sum over all possible inputs from the all possible input set,
yes,
and the time
of each
for
input. Yes.
Now in this particular setting, this merge sort, even the best case is theta n log n, worst case is also theta n log n. Then what is this one?
So theta and log n only.
So this
I
will
mean,
be
n
theta
log
n
n.
log n. So in this case, even the best, worst, any case will be n log, theta n log. Okay.
Oh,
This is the average case, not the expected case. You should remember that whenever you say
yeah.
expectation,
Expected case is different from.
there
Yeah.
has to be a probability.
Probability, yes, yes.
Probability here. Okay, this is a deterministic setting. Is this thing fine? Is this clear? To
Sir,
everybody? Yeah.
like I have a problem with that 2t n by 2 plus order of n. You said that there is a video. I did not.
There is no
like,
video. There is a in the web page. There is a link to the recurrences, and asymptotic notation. There is a previous.
Can you
thing.
just explain it once? So
No,
that,
I will not go over it here at this point at all.
Okay.
Okay. If you want, you can write a mail to us, I mean to TS or A, and we will take care of it. There. It's the plain recurrence relation that has to be sorted, and if you have not, if you don't know it, that's perfectly fine. We will go over it, but then write a mail to us separately, and we will talk about it. It will not just a 2-minute thing that I can just explain like that.
Okay.
I have to go over it a bit more carefully. Okay, good. So this is the average time complexity and the best time complexity and the worst time complexity. Some people ask me about the selection sort. I would ask you to think about that also in the similar direction, similar way. It's a bit more different, slightly different than for the average time complexity. I have not gone. I'm not going over it in this write-up. In this thing. So let me. So let me stop here today. I will leave you with particularly one question. Okay. So in the next class, I will be talking about something called a quick sort. Now, quick sort is interesting because quick sort will have something which has where the worst case will be different from the best case, which will be different from the average case. Complexity, number one. And also there is something called what is a randomized quick sort. Now I don't know how much of it I can cover in class, but what I will do is that I will try to cover as much as I can, and I will also upload a couple of articles that you are free to read them, and very well written articles on randomized quick sort. I will explain all of that in class. It's not a video, and I will have to explain the quick sort. What is a quick sort also. This is what I will do it in next class. But I am leaving with a question, and this is the important question. I want you to think about it. Can there be an algorithm, a sorting algorithm that makes less than n log n comparisons? Note that all the algorithms that we have talked about are called what are called the comparison algorithms, comparison sorts, because we are taking 2 points and asking which of them is bigger and then accordingly putting it, right? So for example, here, if you think of it in the merge sort, there is no comparison over here in this whole thing, but the comparison is here.
If we use index-based sorting, then then
Sorry?
then use index-based sorting.
Whatever is written here. Okay. Now I will if you can come up with the algorithm that makes less than n log n number of comparisons, I would like to hear it. And I will talk about index-based sorting and all possible other sortings also at some point of time. But right now, this is the question that I am asking you to think. By making less than n log n comparisons, can you do it? And the answer is no, you cannot. Okay. So what is index-based sorting? I will come to that later. But this is the question. I want you guys to think about it. Is this fine? Any questions? Hello. Okay, no questions. Everybody understood everything? No doubts? Okay, so good. So in that case, I will stop the class now. One thing that I should kind of remind you guys that on Monday, I have scheduled this tutorial session between 4 to 5 for the JRFs and 6 to 7 for the MTech CS students. If you have any questions, doubts, or anything, please do come at that time to ACMU seminar room. It will be physical. Okay. And for CRS students, it is 5 to 6. But if you are struggling on any topic, say for example, if the CRS students are not familiar with the recurrence, how to solve a recurrence and all, please drop a mail to me or the TS. Okay, and then we will take it from there. Yeah.
Sir, there is no online link for that physical class, right?
No,
Like,
no online.
some of the students cannot attend offline.
So if you are interested in attending offline, then you can come. You can say, let us know again. We can try to see something offline, but I would like to have that one as physical as possible, because so that I can have interaction with you guys. Because if there any demand for offline tutorials, online tutorials, then we can arrange it. You know anybody who wants on
Sir, we have
some of the students cannot
sir, we have
attend
class on Monday.
offline.
You are what? Parthokal, you are JRF?
No, CS, sir. MTCS.
You have a class from 6 after 6
6:30. 6:30. Yes, sir.
Okay, so you have class till 6:30, so it will be after 6:30, so 6:30 to 7:30 or something like that.
Okay.
Okay. Yeah. I mean, this is okay. Yeah, I mean, this is not compulsory. It is basically so that we can interact with you guys slightly more than what we can do in the online setting. Okay, any other questions?
Sir, in the internet, I read that there is something called team sort that sorts in order n for nearly sorted data, but I didn't understand its logic and that.
Okay, that is something that we can talk about. See, that is a special case. Okay, when the data is already guaranteed to be more or less sorted, then how much time does it take? Right?
Yes.
So that is different from what we are talking here. We are saying that you have some data. There is nothing, no guarantee whatsoever about.
Yes.
Okay, we are talking about the worst case setting.
Okay.
Right. So that is slightly different. There are order n algorithms in the internet you will find, but think about it, what they are saying and what I am saying. They will be slightly different. Okay, we will of course talk about it more in more details later on, but right now I let you guys to think about it.
So can you just discuss about the sorting, like in this sorting algorithms applications? Applications means like, where we use like each particular sorting has its own advantages and disadvantages.
Oh, I will do that. I will do that. Let me first finish this stuff. I have not yet finished the sorting algorithms. Okay. Let me first at least explain you the sorting algorithms, and then I will go over all the sorting algorithms in a bunch.
I thought it's the end of sorting.
Of course not. There's quick sort, there's hip sort, there's bucket sort, there's I mean, how many sorts do you want? But we have right now done bubble sort, selection sort, and merge sort, and these three things we have kind of gone over. Okay, so we will be with sorting for some time now. Okay, any other questions? Okay, so if not, then I will see you guys again on Tuesday or Monday if you come for the tutorial. Okay, bye.